Welcome to
Nay.
Do it.
Channel Everyone. Okay, wow, that was energetic. Hello and welcome back. I'm Isabel. And today we are diving into something that sounds incredibly complex, but I promise is going to be incredibly cool. We're talking about making the AI agents that run parts of companies smarter. And we're doing it without needing to retrain the giant brain.
That's right, Isabel. The paper we're discussing today tackles a very practical bottleneck. Many enterprise AI agents, the ones handling IT tickets or logistics, hit a performance wall. They're often built on powerful LLMs, but they struggle because of limited, messy real-world data and a lack of clear feedback on whether their decisions are good or bad.
Exactly, it's the deployment gap. You have a brilliant model in a lab, but in the wild the data is sparse, the scenarios are complex, and you can't just let it learn by trial and error on a live customer database. That's a recipe for disaster.
So the classic solution is more data and retraining, which is expensive and slow. But this paper proposes something different, a lightweight framework. JJ, lightweight is my favorite word when it comes to tech. What does it mean here?
Think of it like a tuning kit, not a new engine. Instead of replacing the LLM agent's brain, we're giving it a better set of instructions and context for each decision it makes. The core idea is called context engineering. We're engineering the prompt, the background information the agent sees, to guide it toward better decisions.
But how do you know what asterisk better context is? You can't just guess. This is where the framework gets clever. It creates a digital twin of the agent's reasoning process, not a twin of the whole IT system, but a twin of the agent's own decision-making logic.
A digital twin of, a thought process. Okay, break this down for me like I'm 10.
Imagine the agent is playing a very complicated board game. Each move is a decision. The digital twin simplifies this. It maps every possible state the agent could be in, like facing a server error ticket from finance department, to every possible action it could take, like check standard reboot procedure or escalate to senior engineer. This map is the digital twin Markov decision process, a model of its own reasoning universe.
And once you have this map, you can analyze the agent's past games, its offline trajectories. Even if some of those past games were played poorly, the framework uses a technique called contrastive inverse reinforcement learning to sift through them. It compares good and bad sequences of moves to infer what the hidden reward or goal should have been.
So it's reverse engineering the rules of a good game by watching both winning and losing plays.
Precisely. It learns the spirit of the law from messy examples. Once it understands the reward, it can solve for the optimal policy, the best strategy to play the game on our digital twin map.
And that optimal strategy from the twin world, how does that help the real AI agent?
That's the final, elegant step. You don't make the agent follow the twin's policy directly. Instead, you use that optimal policy to rewrite the instruction manual asterisk. You engineer the context. So when the real agent faces that server error from finance state, its prompt now contains subtly better hints, a clearer prioritization, or a more relevant piece of knowledge, nudging it toward the action the digital twin identified as optimal.
So it's a feedback loop. Observe the agent, build a simple model of its mind, figure out a better strategy on the model, then use that strategy to give the agent better hints in real life, all without ever changing its core code.
Exactly. It's a pragmatic wrapper for improvement. In their case study on IT automation tasks, this context engineering framework led to significant and consistent performance jumps across the board.
The implications are big. This model-agnostic approach means it could be applied to many existing enterprise agents. It addresses the data scarcity and safe learning problem by using offline data and simulation on the digital twin. It's a powerful tool for moving from a prototype agent to a robust, deployable one.
This is fascinating. It feels like we're moving from just building AI brains to also building AI coaches. Tools that can sit alongside these agents and help them perform at their best by understanding how they think and guiding their thoughts. Thank you both so much for climbing this ladder with me today.
Thank you, Isabel. Always a pleasure.
Thanks for having us.
And thank you for watching. We'll see you next time.